You're listening to the N2K Space Network.
And now, a word from our sponsor, SpyCloud, the cybercrime analytics leader. SpyCloud disrupts cybercrime by telling you what criminals know about your business and your customers, so you can take action to prevent ransomware, session hijacking, account takeover, and online fraud. SpyCloud constantly recaptures and analyzes new data from the criminal underground, including credentials, session cookies, and PII siphoned from malware-infected devices. With knowledge of the specific exposed data criminals have in hand from InfoStealer malware on managed and unmanaged devices, security teams can respond with a more efficient and effective process called post-infection remediation that fits seamlessly into existing incident response frameworks. Get SpyCloud's post-infection remediation guide outlining the 7 steps for preventing a malware infection from becoming a full-blown ransomware incident. Visit spycloud.com/cyberwire. That's spycloud.com/cyberwire. And we thank SpyCloud for sponsoring our show.
You know, as long as humans have been exploring space, we've also been creating a bit of a mess. Orbiting our planet are thousands of dead satellites, along with bits of debris from all the rockets we've launched over the years. But who's tracking all the mini pieces of junk up there? Well, this month marks the beginning of Sintra, a 4-year program to start tracking space debris that has been both flying over and under the space debris radar. Objects that are not too big and not too small, but just enough to cause the biggest of problems in low Earth orbit.
T-minus 20 seconds to LOS T-dress. Go for deploy. Roger roll.
Today is August 3rd, 2023. I'm Maria Varmazis, and this is T-minus. IARPA launches an initiative to track space debris. NOIRLab halts observations after a cyberattack. UK Space Agency to fund Earth observation tech. And our guest today is friend of the show, Jack Cohen, Program and Mission Manager at AstroDigital. Stay with us. And now let's take a look at today's Intel briefing. Today kicks off an encouraging new enterprise to address an existential problem that worries a lot of space watchers: space debris. There are ongoing efforts to track abandoned spacecraft and a mosaic of efforts to track space trash floating in orbit at various sizes. But current efforts can miss large swathes of space debris. For example, right now, NASA's leading efforts to model, but not track, tiny debris, less than a millimeter in size, and the Department of Defense tracks large debris over 10 centimeters in size. So that leaves debris including and between the tiny 1 millimeter and the large 10 centimeters in size as kind of an unknown. The U.S. National Science and Technology Council wrote in a 2021 report that 100 million debris objects over 1 millimeter in size are estimated to be in orbit over Earth right now, but only about 1% of that debris is being tracked. And it's the bits in that Goldilocks 1 millimeter to 10 centimeter small size range that can pose the largest risk to missions in low Earth orbit. So, last month, IARPA, or the Intelligence Advanced Research Projects Activity, announced the creation of Sintra, the Space Debris Identification and Tracking Program, to go beyond modeling and specifically to detect, track, and characterize all that small, not tiny or large, but 1 millimeter to 10 centimeters small, space debris. And Sintra kicked off officially now at the beginning of this month, starting what's anticipated to be a 4-year program. Sintra will be using existing sensor infrastructure, including ground-based radar, optical sensors, and tracking satellites to do their work. The 4 prime contractors working on Sintra are ATEC, Advanced Space, SRI International, and West Virginia University Research Corporation. And the test and evaluation team for Sintra are MIT Lincoln Labs, Naval Research Laboratory, Los Alamos National Labs, and Johns Hopkins University Applied Physics Labs. We're learning today about a cyber attack that happened on Tuesday, August 1st at NSF's National Optical-Infrared Astronomy Research Laboratory, or NOIRLab. It's the U.S. Center for Ground-Based Optical-Infrared Astronomy that's a joint effort between the U.S., Canada, Chile, Brazil, Argentina, and South Korea. And because of the cyber attack, all observations had to be suspended at the Gemini North Observatory in Hawaii. While the NOIRLab IT security team work out the depth of the attempted attack on their system, all Gemini Observatory computer systems have been completely shut down to prevent possible damages. This includes not only the connected computer systems, but also both of the Gemini telescopes, the North in Hawaii and the South in Chile. Now, thankfully, at the time of the attack, both North and South telescopes were already not in use. Possibly we have the full moon to thank for that timing. But the telescopes were safely stowed or shut down when the attack occurred, and both South and North telescopes will continue to be closed down while the investigation continues. The Gemini website and proposal tools are also offline for the time being. According to the NSF press release about this incident, thanks to fast action taken by the NOIRLab IT security teams, there does not appear to be any damage to any of the observatory computer systems or telescopes. Details are admittedly scant on the nature of the cyber attack right now, so we can't and shouldn't conjecture if this attack was random or targeted, but it's a good reminder for observatories and research centers of all kinds to stay vigilant to potentially systems-disabling cyber attacks like this. You might remember that Atacama Large Millimeter Array, or ALMA, in Chile was also hit with a cyber attack last October that forced operations to shut down for almost a month. NOIRLab is doing an investigation into the nature of the security incident, so when there is information to share from NOIRLab about the nature of the attack, we'll be sure to share it with you. There is no ETA at this time for when the observatory will come back online. The UK Space Agency has announced a new initiative to fund Earth observation technologies. The agency is committing £15 million, and that's $19.1 million US for those of us on this side of the pond, to support the research and experimental development of space-based instruments aimed at supporting a range of environmental services. The Earth Observation Technology Program funding is delivered by the Center for Earth Observation Instrumentation and is part of a £400 million, or $511.8 million US, package announced in November of last year to support the UK's Earth observation sector. The funding will cover Pathfinder projects of up to £75,000, fast-track projects of up to £250,000, and flagship projects of up to £3 million. And staying with the UK, the government has published a National Risk Register, and that's an annual assessment of the most serious risks facing the nation. And a number of the risks identified are in the space domain. The risks include disruption of space-based services, loss of positioning, navigation, and timing, severe space weather, and deliberate disruption of sovereign space systems and space-based services. The UK Space Agency says that space-based tech is increasingly important to everyday lives, and therefore protecting it is vital to the nation's security and prosperity. The report also warns that the cost of a potential disruption to global navigation satellite systems has been estimated to be over $1 billion US per day. Moving over to China now, and researchers from the National Space Science Center under the Chinese Academy of Sciences and the China Lunar Exploration and Space Engineering Center of the China National Space Administration have released a paper on the country's lunar probe Chang'e 7. The paper details how the vehicle, which is supported by a hopping detector, will look for water ice in the shadow pit near the coveted lunar South Pole. The vehicle will carry a water molecular analyzer on a mini-flying probe to obtain water molecules in the frost layer on the lunar surface. China plans to launch the Chang'e 6 to land on the moon next year to collect samples from the far side of the moon before sending the Chang'e 7 probe in 2026 to investigate resources at the South Pole. And China also held a launch earlier today of its Long March 4C carrier rocket. The vehicle launched a Fengyun 306 meteorological satellite into orbit. Today's launch is the 481st flight mission of the Long March Carrier rocket series. That is impressive. Moving back to the U.S. now, and Innovative Rocket Technologies Incorporated, also known as iRocket, has signed a cooperative research agreement with the Air Force Research Lab to allow the startup space launch company to use a government facility to test and mature its technology for reusable rockets. iRocket expects to use the facility located at Edwards Air Force Base to develop engines and stage technology for the company's fully reusable Shockwave launch vehicle. Test Site 156 is one of only 4 stands in the entire United States capable of 10 million pounds of thrust. That is some power. The U.S. Navy, Air Force, and NASA have held a joint exercise to simulate capsule recovery off the coast of San Diego. The drills were held as a critical dress rehearsal for Artemis II, the first human lunar mission in over 60 years. A mock-up of the new Artemis's Orion spacecraft was repeatedly placed in the ocean by a transport dock ship, which then filled the capsule with 4 officers and sailors from the Naval Air Station, North Island. The capsule was safely extracted and transferred back to the ship by helicopter, and Orion was guided back by boat crews. The 4 astronauts assigned to the Artemis II mission, Christina Hammock-Cook, Reed Weissman, Victor Glover, and Jeremy Hansen, will travel to San Diego next spring and participate in splashdown recovery drills with the Navy ahead of their mission to the moon. In-space logistics provider Atomos Space and solar energy company Celestial Incorporated have announced a multi-mission sales agreement for a minimum of 20 kilowatts of Celestial's ultra-thin, low-mass, radiation-hardened solar blankets. Celestial's photovoltaic system will be demonstrated on Atomos's first mission, scheduled for February of next year. If successful, the technology will provide primary power for Atomos's solar electric orbital transfer vehicles on 2 subsequent commercial missions, beginning in late 2024. Now, that is super cool technology. I can't help but wonder if they're going to develop solar blankets for houses, because I would definitely want that. And that concludes our Intel briefing for today. As always, we've included links to all of our stories for today in our show notes. We've also included a few stories that we didn't get to in our newsread, including developments in Florida at the Spaceport Commerce Park in Titusville and a new park groundbreaking in Huntsville, Alabama. You can find those stories and a lot more at space.n2k.com. Hey T-Minus crew, if your business is looking to grow your voice in the industry, expand the reach of your thought leadership, or recruit talent, T-Minus can help. We'd like to hear from you. Just send us an email at space@n2k.com or send us a note through our website so we can connect about building a program to meet your goals.
This episode is brought to you by Palo Alto Networks, the leader in cybersecurity. As AI-driven attacks increase, organizations can't afford to have network security that's stuck in the past. Discover how Palo Alto Networks can help you predict what's coming and proactively secure against it with a zero-trust, AI-powered network security platform built to secure whatever, whenever, wherever. To learn more, visit paloaltonetworks.com/network security platform.
Our guest today is Jack Cohen, Program and Mission Manager at AstroDigital. Now, Jack's a friend of the show who joined me for a catch-up chat on the latest at AstroDigital, and also to get his view on the anomalies that affected some of the missions on the Transporter 8 rideshare.
It is not uncommon for there to be anomalies, especially during the LEOP portion of the mission. It's unfortunate that these happen, and everyone is so invested, and a lot of the times these transport missions are the first vehicle for an organization to launch. So it can definitely be heartbreaking every time that we see anomalies happen, and everyone hopes that first contact you're getting good signal and immediately seeing that the spacecraft is in sun track or whatever kind of nominal mode that shows everything's working. But of course, it doesn't always go that way. And the best thing to look for in that is kind of if there's a path forward, if you can do more with the vehicle, or recover fully and do the mission from there. It's not uncommon. It's unfortunate, but it's the reason that a lot of people do these technology demonstration missions. And those are, at the end of the day, actually quite a bit of cost savings, because if folks spent all of their budget on the full mission and really didn't have the opportunity to learn, they might be in a much worse state and not have the ability to recover, whether it's from the technical point of view or the business side of things.
Let's shift over a bit into, we're sort of on orbit right now, so let's stay on orbit for a moment. So I know that you wanted to talk a little bit about some of the on-orbit services that, maybe I'm phrasing this wrong, that AstroDigital offers. Can you get a little bit into detail on that?
Well, AstroDigital doesn't necessarily directly offer in-orbit services in terms of like satellite docking or sat-to-sat servicing. What AstroDigital does offer is we can operate the spacecraft that we manufacture for our customers. And with that, we can bring all of the talent, the knowledge, the technical team from engineering that worked on building the spacecraft that then can support our ops group. And that having that full team has been really helpful, especially when things aren't going right. Anytime that there's an anomaly, having the ability to have a full team that was there from the start of the design effort for a program. So one of the cool parts about being part of the AstroDigital Satellite Operations Group or SatOps is that we get to operate a very diverse group of spacecraft. I don't know if it's fortunate or unfortunate that we don't just have a giant constellation of 100 of the same spacecraft. We have quite the opposite. So while we do support constellations, we also support a bunch of very unique programs. And being able to be a part of that means that no day is going to be the same. It's definitely not boring. So with each mission comes its own kind of list of complexities, whether it's an OTB mission where you're trying to get to a specific orbit by utilizing a SpaceX transporter launch. You can go up relatively low cost, but you're going to SSO and you're going somewhere between 500 and 550 kilometers. So if you need to go anywhere else, especially if it's a mid-inclination destination that you're looking for, there's quite the effort to get there. And so we've had the ability to show some pretty powerful biprop capabilities with our spacecraft and did some pretty complex maneuvers. Yeah, we've done everything from that to small constellation of Earth imaging spacecraft. So those have a completely different concept of operations, and being able to have operators swap between those two missions, but be able to support them is very important. We've also been able to support customer payloads that do weather monitoring. Most recently, we've had two different spacecraft launch as part of that. Will be very exciting to see once we're past the commissioning phase what those spacecraft are capable of. And then we're still doing a number of different technology demonstration missions, including then the actual in-orbit servicing vehicles. And that's been really cool to be part of these demo missions, because you get to see a company bring something to life for the first time and bring something to market.
Yeah, absolutely. That is such a cool part of the job. I imagine just seeing that cutting edge that right there as it's happening. I'm going to switch gears completely. We also wanted to talk about ground station. My first question is, why doesn't it get the love that it should, given that it is an important part of the whole system, right?
The first time you ever get to lay hands or see eyes on space hardware, all the attention goes to that because it's cool, it's shiny, it's new, it's unique. It's definitely unlike anything that we have terrestrially. So I think that all the effort goes into designing that and making that happen, like making that spacecraft come to life and be real. But in the background are typically one or two people that are eventually going to have to operate it, saying, hey, how are we going to communicate with it?
Kind of important.
I think that's a reason why people aren't necessarily looking at it as early as they should be. And the timeline is really just the only constraint timeline-wise is as a result of the regulatory hurdle of having landing rights and transmit rights from each ground station. And we have ground stations all over the world, and AstroDigital partners with RBC Signals, LeafSpace, KSAT, AWS ground stations. We're still in talks with several others that we're hopefully going to onboard. The interesting thing is that each one of those providers has stations worldwide, and each one of those stations is at a different place that requires a different regulatory process, given the nation that's hosting it.
Of course, yeah. So what kind of timelines are we looking at then?
It could be as little as 0. Like there are certain locations that you can start operating immediately. However, there are other stations in other parts of the world that take more than a year to potentially 2 years to license. And so if you're not thinking about that super early in the mission, and for a lot of people, the entire mission, like to from concept to contract, ATP to launch is less than that. So it really, there are a couple regulatory hurdles when it comes to the ground segment that need to be thought very early on in the mission.
I was going to say 2 years lead time. My goodness, that's a lot.
Yeah. Having so many different network providers, we benefit from being able to have good relationships with them and being able to onboard new spacecraft for upcoming launches is gotten to be very just streamlined. And so we're able to save money on the regulatory side by licensing a group of spacecraft instead of individual spacecraft. And then we're able to do a Costco discount or a wholesale discount on passes. So by being able to operate so many different spacecraft for several different customers, all of those customers are able to benefit from lower prices than they would get if they went directly to those providers.
So given the lead times involved in the regulatory hurdles, I imagine that you and your company have dealt with, as I said, as you mentioned, the sort of bulk discount's not the right word, but the negotiation there. But I'm curious what kind of best practices that you have to pass on to customers or anyone listening who might be going, oh yeah, I do need to deal with that, and maybe haven't gotten in front of that as quickly as I should have. What are some best practices for them?
My recommendation and what we've started doing at AstroDigital in the last year or two has been to bring in more of the satellite operations folks pretty much at the critical design review point, where everything has been discussed in terms of each mission being so unique. Everyone needs to understand, hey, if this CONUP requires an image to be downloaded and we only have a 6U or 16U that doesn't have a high-speed radio in it, how many ground stations are we going to be required to download that image in the time that we need? Really just closing the loop on making sure that the mission design is still meeting the requirements from an operations point of view and not just from a spacecraft capabilities point of view. If you only sign yourself up for one TT&C radio and one TT&C ground station, you're going to be limited by the number of contacts you have at that ground station and then limited by the data rate of your TT&C radios. Fortunately, AstroDigital has a phenomenal 4th generation K-band radio that we call XCOM, and it's really more than just a K-band radio. It's got a terabyte of storage on it for payload data, and we're seeing about 1.6 gigabits per second on orbit right now. We should be able to get up to 2.4, but even only having that one radio and one ground station that's capable of interfacing with that radio, it can meet the requirements of a very large, heavy dataset payload.
Jack, thank you so much for enlightening me this time. Again, it's always a delight to speak to you, and I always learn a ton. So thank you so much for speaking with me again.
Absolutely. Thanks for having me. It's been phenomenal to see what you guys are doing on this show, and it's a daily enjoyment for me on the weekdays.
We'll be right back.
Now, a word from our sponsor, the Johns Hopkins University Information Security Institute, currently seeking qualified applicants for its innovative Master of Science in Security Informatics degree program. Study alongside world-class interdisciplinary experts and gain unparalleled educational, research, and professional experience in information security and assurance. Interested U.S. citizens should consider the National Science Foundation's CyberCore Scholarship for Service program, which covers tuition and a $6,000 annual professional development allowance, as well as providing a $37,000 additional annual stipend. Apply for the scholarship and the fall semester by March 1st. Learn more at cs.jhu.edu/MSSI.
Welcome back. Now, many discoveries from space admittedly leave us scratching our heads and going, huh? And the latest one from the James Webb Space Telescope is perhaps telling us that the cosmos is just as confused as the rest of us. About 1,470 light years from Earth in the Vela constellation, there are two actively forming young stars, a dazzling display named Herbig-Haro 46/47 by astronomers. Now, Webb's outstanding image of these stars forming is a dramatic nest of swirling gases and light, and just a little bit beneath it, nestled between a whole bunch of swirling spiral galaxies, is a question mark. Yes, a question mark. And no, it's not one of those phenomena where, it looks like a question mark if you squint your eyes and turn your head, and maybe it kind of looks like that. No. It's very cleanly and plainly like someone typed one out, very obviously a red question mark. Now, this is the first time astronomers have ever seen this object. Its discovery is new, thanks to Webb, as it is very, very far away. Now, current theories are that galaxies interacting or merging are probably what caused this familiar shape out in space. But there's no word yet from typography nerds what font the Cosmos prefers to use, though I will say it does look like that question mark has a bit of a serif. So thankfully, that rules out the universe preferring Comic Sans. That's it for T-Minus for August 3rd, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T-Minus are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karpf. Our chief intelligence officer is Eric Tillman. And I'm Maria Varmazes. Thanks for listening. We'll see you tomorrow.